So this problem comes from 6.2 and it says find all degree solutions in the interval from 0 to 360 degrees. Round to the nearest tenth of a degree if necessary, and then use the calculator to verify the solution graphically. All right, so here's the problem. And in this problem, I do see that I have a cosine double angle. So typically when I'm solving these problems where I have trig functions in them, I want to have everything in the same trig function. And this one is not. I have sine and cosine, but this specifically, this is a cosine double angle. So I'm going to go to my trig cheat sheet and I'm going to look at my cosine double angles, and there are 3 ways that I can rewrite the double angle of cosine. And since this one is partially in sine, I'm going to choose to write it like this. So this bottom one here. So instead of writing cosine 2 theta, I'm going to write this as 1 minus 2 sine squared theta. So I replace the cosine 2 theta with this. And now I'm going to try to simplify it. So this minus 3 will get distributed to both of these terms. So I have minus 3, 3 times 1, negative 3. The negative times the negative here will give me a positive, and then I'll have 6 sine squared theta is equal to 0. And now I can combine these two to become 10 sine. These are like terms. They have coefficient of 4 and 6 on them, so I'm going to combine them to give me 10 sine squared theta minus 3 is equal to 0. So I've combined both of these. And now I want to try with these problems, I always try to isolate the sine of theta. So the first thing I'm going to do is add 3 to both sides, and I end up with 10 sine squared theta is equal to 3, and then I'll divide both sides by 10, and the 10s will divide out here, and I'll be left with sine squared theta is equal to 3 over 10. Now, let's see, where do I go from here? So, this is sine squared theta. I want just sine of theta, so I'm going to take the square root of both sides, and I'll get sine of theta is equal to plus or minus the square root of 3/10. So now we need to generate all the angles between 0 and 360 that give the sine of theta a trig function value of square root 3 over 10. And let's make sure if I do square root 3 over 10, I know I'm going to get a value between negative 1 and 1, and I do. So and this is plus or minus, so even if it was negative, it would still be between negative 1 and 1. So remember, this is a trig function value, and I need to find the angle. In these problems, it's looking for the angle. So I'm looking for this angle here. So in order to give me that angle, I am going to say theta is equal to the inverse sine of the square root of 3. And I keep writing this incorrectly. The whole thing is square root 3 over 10. So everything is underneath the square root symbol. Now I'm going to put this in my calculator. This will give me the reference angle in quadrant 1. And I will need to find So in quadrant 1, sine's positive, quadrant 2, sine's positive. So I'll have to find it in quadrant 2. But this is plus or minus square root 3 over 10. So then I'm interested in quadrant 3 and 4 also. So I'm going to have a total of 4 angles here. And so the reference angle, let's put it in the calculator and see what it is. $33.2. I'm rounding to the 10th place. So that's in quadrant 1. So the angle is equal to the reference angle. So in quadrant 1, it's 33.2 degrees. And then in quadrant 2, you find the angle by taking 180 and subtract theta prime, or theta hat. And so in quadrant 2, it would be 180 minus 33.2. And putting that in my calculator, I would get 146.8. Then in quadrant 3, the angle is equal to theta 180 plus theta hat. So it would be 180 plus 33.2 degrees. And that would give me to 13.2 degrees. And then the last quadrant, the angle is equal to 360 minus theta prime. So it's 360 minus 33.2, which will give me 326.8. So I've gotten, these are my my 4 answers. 33.2, and then I've got 146.8, 213.2, and 326.8. Those are the angles. They look like this. They are 33.2 degrees from the x-axis, just in the 4 different quadrants. Because of this plus or minus sign, I need one from each quadrant.